form of rows and columns. For example, you talk about a table in RDBMS. It will have a proper rows and columns. You talk about Excel sheet. It will have rows and columns, and each cell will have a value. Okay, like each cell in Excel sheet, each cell in a table of the RDBMS, they will have some values. Unstructured data set are those data which you cannot directly represent in the form of rows and columns. For example, you talk about the images. Images, although it is structured in the case of height and width, but when you go and read the image, there will be pixels, and each pixels will be having a separate RGB value. That each pixel will have 3 values. That means each cell does not have a particular value. It contains more than one value. So sometimes this type of data, same way video, the data which are coming from sensors, sometimes the data might be missing or something might be happening. So unstructured data are those data which, in layman term, if I say, you cannot directly represent in the form of rows and columns. There's another data which is known as semi-structured data. Semi-structured data are those data which you can represent in both structured and unstructured format, both the things. It's a midway between the structured and unstructured data. For example, you talk about email. You have to, from, body, subject. So this is a common format, but what goes inside the body, that's not defined. You talk about the HTML page. HTML page, the sections are divided, but what goes inside that section, that is not divided. So a section of your data which is structured, and there's another section which is unstructured. So that those type of data are termed as semi-structured data. So whenever we talk about machine learning, okay, whenever we talk about the supervised learning we are going with, we always focus on the structured data. If your data are not structured, then you will have to make it a structure. Otherwise, you cannot go with the machine learning concept. Now, when we talk about the machine learning, okay, there are two things which comes in the mind. Let me just put it this way. Yeah. In machine learning, you have two things which comes into our mind. First one is your supervised learning. Okay, supervised learning, and there is unsupervised learning. Supervised learning, where you have a set of input and a corresponding set of output. That means I will give my system a set of input, which I can call it as a features, and a set of output, which can be classes or the prediction of the stock prediction or the prediction of a price of a flat. So you will have some features, like if I'm talk about the features of a flat prediction I'm talking about. So in that particular case, I will be having the price of a cement, the price of a floors, and so on. And what is the total cost? So that is the input and output. So what we will do, we will give it to the system. We'll build some model on the basis of that. And then in the test phase, I will be giving a set of input, only the input, that is the future data or the test data. System, based on these data, it will look, it will analyze, and it will give me the prediction. So that is your term known as your supervised learning. That means there is something which helps you to supervise. In unsupervised learning, we only give input, we design some steps, and later on during the test phase we just give the input. So whatever system based on these rules decide and give me, that I will take it as an output. So neither the system nor the, what you can say, the nor the experts know what will be the output. So we cannot force on that. So supervised learning, if you talk about, that has two sections. First one is your regression analysis. Second one is your classification. So in this supervised learning, we have your regression, and actually my pad stopped working yesterday, it got slipped. So regression, and the second one is classification. Okay, anyways. So if you see over here, now I want all of you to just ping me on the chat. Suppose I ask you, let it be irrespective of any place. How much time does it take you to travel from your home to your airport? I just want all of you to answer that. Is there any chat? Yeah, chat is there. Please ping on the chat. Just a random guess. I just want to see, or whatever you feel like. My simple question is, how much time will you take to travel from your home? Yeah, so I got some answers like 2 hours. What about others? Yeah, 30 minutes. Okay. Now, see, guys, when I asked this question, how much time it will take? Now, the thing is, you said you analyzed your historical data and you gave me the time. But in different states, if we talk about Delhi or a Bangalore, okay, if the flight is around 7 o'clock, that means if from 4 to 5 I have to travel, that will be a huge traffic. It will take me around 3 hours. At 2 a.m. in the morning, it might take me just 45 minutes. So that means there is an external parameter on the basis of which the duration is changing. The time travel, the time which took me to travel from my home to the airport, this distance is fixed, but at different time intervals there will be traffics, and because of that traffic there will be change. Sometimes it might take 4 hours, sometimes it might take 3 hours. So if I say that, if I be more specific and say that how much time it will take me to reach airport at 2 a.m., or if I say how much time it will take me to reach airport around 6 p.m., so both the times will be different. Same way, over here, if you see, we have a units. Suppose we have some units and some minutes. Now, the thing is, I took my laptop to the service center, okay? And the service center has this information like if one unit of the part is being replaced, it took this much amount of time, let's say 23 minutes. If two parts are replaced, it took around 29 minutes, so on. So imagine I took my laptop to the service center, I gave it to them. Now he says me to come after 2 hours. Okay, that means around 120 minutes. Okay, now the thing is, if 120 minutes is being said, that means around 8 parts should have been replaced. Suppose there are 10 parts which needs to be replaced, that means another 40 minutes I will have to wait at the service center. That means after 2 hours when I go over there, another 40 minutes I will have to wait. If only one part was supposed to be replaced, in that particular situation, I will have to, means my system was kept idle in the service center for around 100 minutes. That means in both the cases, as a customer, I am not satisfied by the service which they are providing. In either case, either I have to wait at the service centers if more part has to be replaced, or my laptop is kept idle and I need it urgently. That means when we take mathematical mean, okay, the average, if you talk about, it does not always provide us the best solution. Okay, because this minute is actually dependent upon the units. Okay, and this unit is an independent entity. So if I say the average of the minutes, if I take, it comes to 97 minutes. That means according to me, all the laptops has to be will be serviced in around 97 minutes. That means around 6 part has to be replaced, but that's not true. Median, it comes around 96.50. Okay, so neither mean nor median can justify this. See, it's our basic assumption based on our historical information. We just take the mean and we proceed. But we have to keep into the mind what are the dependent on what are the independent parameters. Now, let's see this data. Okay, if we plot this, so these are the parts which are being replaced, and this is the minutes which we take to change it. Now, This is the mean. Okay, that means this is my prediction, which let me put it as y cap. Sorry, it's not working at all. Y cap. Okay, that means if 2 unit was replaced, okay, still my prediction is 97. So in that particular case, the error will be around 67. So this is my error. That is, this is the actual data, and this line, wherever it intersect, this is my predicted data. Now, the thing is, this mean and median we cannot go with. But there's an interesting thing which we have to look at. As the number of units which are being replaced, that is increasing, the number of minute is also increasing. That means they are dependent upon one another, and linearly they are dependent. So this graph is known as a scatter plot. By looking at a scatter plot, you can say that whether the data is linearly or non-linearly or not even dependent upon one another. Okay, so over here we will try to go with the regression analysis, like mean. If I talk about a mean or a line, a plot, if we say, okay, the line we over here, that is the line we determined by y equals to mx, sorry, mx plus c. Okay, so that is the equation of a line that we have studied in standard 7. So if I see over here, there is no slope. That means y equals to c in this particular case. So what we have to do is we have to find out a line. This is y equals to c. Okay. So what we have to do is we need to find out a line which will best represent our data. That means regression analysis, simple linear regression analysis, the one which I'm talking about, it's nothing but it's just an equation of a line, that is y equals to mx plus c. So m represents your slope and c is your intercept. Now the thing is how we represent that. Now that's the question we have. So over here, if you see, just let's focus on linear form, and we just focus on only one parameter, that is b1 x1. That means only one feature, like in our case the units which is being replaced, and that is this is the unit, okay, and this is the yx will be the prediction, okay, of the minutes. Now the thing is, in this particular case, if you see, beta naught is nothing but it's just your intercept, that is c, and beta 1 is your slope. If there are more features, suppose if it's a 3-dimensional, it's a box like data, in that particular case a plane will separate that. Like in 2-dimensional data, we have a line which is separating it. Now the thing is, over here, this linear form, how do we determine beta naught and beta 1? Same way you have non-linear form, you have polynomial forms, and you have logistic regressions and so on. Okay, so if you see over here, this polynomial form you have simple linear regression, that is beta naught plus beta 1 x1 plus epsilon. What is epsilon? That I will explain it to you. It's the error in the training data. Then you have beta 1 x1 and the that is the slope and the intercept. Same way, if the features are more features are increasing, we call it as a multiple linear regression. That means instead of just based on the units, if it depends upon the model as well. Okay. Same way you have polynomial form, quadratic form, logistic form. Now there's one important question thing to remember. Although we call it as a logistic regression, okay, but logistic regression is not a regression, it's a classification. Now what is the difference between a regression and classification? In case of regression, since we are representing anything by a line, okay, and the range of the line can be minus infinity to plus infinity, that is the nature of a line. Okay, that means whatever we predict on the basis of this, it can take any value, it can take continuous value, it can take from minus infinity to plus infinity. But if we talk about, let's say, binary classification, suppose a patient is a diabetic or a non-diabetic, okay, or the power failure, yes or no. Okay, so if there's a binary output which has to come, you have to classify something. In that particular case, your range would lie between 0 to 1. That is a sigmoid function. Okay, if I get the time today, I will explain it. Otherwise, you can read about that. So that is the range between 0 to 1. Now, the thing is, when with the logistic form, when we are talking about, so we are just classifying it. And this is the one which it takes the range. Guys, is it clear now? Till now, any doubts, anything? Okay, there's a question, why should we apply regression on this data? Okay, see, Shankar, by looking at the data, we should be able to understand. Suppose you see over here, there is a chance that this minute might be dependent upon the units. I'm not sure on that. So for that, we went and we saw the scatter plot. Okay, in scatter plot, we found that they are linearly dependent. If you're not sure, if the plot is not giving you the best result, then the correlation you will have to find out. Correlation between the two variables. Again, and if see that is significant or not. If that is a significant one, then you go with the linear regression or you drop it. But if you're talking about the data perspective, you see the one which you want to predict whether it's a continuous number or it's a discrete. If it is a continuous number, that means it might take any value between minus infinity to plus infinity. So that is the output of a simple linear regression. And if it's a discrete, that means it's a part of a classification. Shankar, I hope I am clear. Shankar P?
Whenever there is non-linearity, then we'll apply regression, correct?
No, it's not like that. Linearity, see, linear regression, the basic assumption is they have to be linearly dependent. Then you apply linear regression. For non-linearity, you go with polynomial or quadratic.
Yeah.
It has to be
so if it is linear, there is no need for you to apply regression, correct? You can easily classify. Because it's a straight line. Y is equal to mx plus c. It's a complete straight line. Am I correct?
Yeah, correct. Y equals to mx plus c. If it's a linear,
and
that is
linear,
the perfect
straight
thing.
line.
But
yeah, and then you can classify between the two. If there is no, if there is the line is not there, and if it is non-linear, then only you have to apply regression. Correct?
No. Let me come to it again. Simple linear regression, the formula is of a line. It's again a regression. Okay. If it's a non-linear, you apply a polynomial regression. That is also regression. So this y equals to mx plus c, it's a regression analysis. It's a simple linear regression. If you see over here, the forms of the regression analysis, this is a simple linear analysis, the simple linear regression, which is being represented by a line. Did you get my point? So it's again a regression analysis.
No, I didn't get your point, because if it is my question is, say if it is the data is giving you left hand side and right hand side, let us say it's a positive correlation exists between the two, and if you are having a straight line, then there is no need for us to apply regression, correct? You can easily classify.
Shankar, tell me how you're determining the straight line, how you're getting a straight line.
Because if when you said you put a scatter plot, the scatter plot will give you a,
yes, that's what I'm saying, Shankar. That's what I'm saying. Regression has two forms: linear form, this one, and it has non-linear form, this one. Okay. In the linear form, if you have one dependent and one independent, we represent it by a line, like in this case. Okay, and that line is not a line, it's actually a formula. This is a predicted formula. You have to determine C and the M value. The line which you are saying, it's again a regression. It doesn't mean that if it is a non-linear, then only we apply a regression. A line is actually a representation of simple linear regression. Let me just put it this way, Shankar. And this is for everyone. You see over here, this regression analysis, like I said, I will come back to you again, Shankar. Time taken to repair the computer, that is the prediction of Y, and beta naught plus beta 1 into number of units which is being replaced. So that means this is my C, this is my M. Now, this was the initial model which we took. We just took two random values of C and M. Okay, we just took two values of random C and M. If we plot this, you see these lines over here, model 1, that is 10 and 12 and 6 and 12. These are representing the predicted values. Okay, and for each values, let's say I'm talking about this one. For this line, this will be the error. For this line, this will be the error. Okay. Now, if you see over here, if I take the line as my output, expected output, okay, and this are my observed time taken. If I take the error and I sum it up, it is almost equivalent to 0. Why it is all? Just a second. Why it is equivalent to 0? Because the data is distributed both the sides by the mean. Okay. So in that particular case, I cannot simply take the sum of errors. I will have to take sum of squared errors, which comes around 27,768.36. Okay. So you remember this value. If I have taken mean as my predicted value, if I take it by the line, like 10 plus 12x, that one I am taking. Okay. So this is my observed value. This is my expected value. Now you see over here, in both the cases, whether it's observed or the expected, in both the scenarios, as the number of units are being increased, they both are increasing. In this particular case, my sum of squared error is 4,993. Earlier it was 27,000. So almost 5 to 6 times it has reduced, because I'm able to represent, I'm able to give a slope to it, which is being very near to my data. Same way over here, we get this 5,001. Okay. Now this is the error which is being passed. Now, this error, since it's an error, I'm not sure whether that the line, that 10 plus 12 and that one 10 and 16, these two line, which is 4993. This first one gave me 27,000. This gave me 4,993. That is almost 5,000. This also gave me around 5,000. So I cannot say that this is the optimal result, because that's a random value I have taken. I need to get a line which represents my data. Drawing just a line will not help. So how do we get that? You see over here, this is the formula which we get: y equals to beta naught plus beta 1 x1. Okay. Now let me put it this way. This is my predicted output. My sum of squared error, if I talk about, that is your y minus y cap whole square summation. Now this y cap is nothing but that is y minus beta naught. Y is my actual value, y bar is my predicted value. Beta naught minus beta 1 x1 whole square. Okay, that is my predicted value, right? And this value y we know, okay, sum of squared errors. I need to minimize this. I need to get it to, let's say, 0. So what I can do is, in order to get the beta naught and beta 1, Okay, first I will differentiate with respect to beta naught to get the values of beta. I will equate it to 0, and then I will differentiate and I will equate it to 1. So on the basis of that, if we get, you get this value. You equate to with respect to beta naught and you equate sum of squared error has to be 0. Then you get this value. Then differentiating the equation with beta naught and equating it to 0, we get this particular value. So this is how you get beta naught and beta 1. When we solved it, okay, the same thing. This is a R script. Okay, same thing. Based on this, we got beta naught and beta 1. We got this values. That is beta naught is 4. That means now my minutes, my predicted y, okay, it's actually 4.16. Okay, it will be in the next line. Where it is? Okay, it's not there. 4.16 plus 15x. Okay. Now I can put the values and I can get my results. So same thing if I did. Now this is the line which is being best represented. Okay. Now in this particular situation, if you see the error, okay, the error is around 348. That is the optimized error I am getting. Fine. So this is the best fit model that we have achieved. So that is your simple linear regressions. This is the formula using LM which you can get it. So simple linear regression doesn't mean that it's just a line. Okay, it's a representation of your data. And regression doesn't mean that it's a non-linear form. It can be in the linear, it can be in a non-linear. How you represent your data, that is much more important. If it has been a multiple linear regression, in that particular case, you will be having more features. You will be having more features. Like instead of just units, you will have more features of that. Okay, that is a representation by a plane. If you have just one features, that is a presentation by a line. So there are two forms of regression. Am I clear, Shankar? And other guys, any other doubts? Then I'll move to classification. Any other questions? Any other doubts? If you have, guys, please respond. How do we differentiate for the functions to minimize the error? Use any software to Balmurugan, what you can do is, if you want to go mathematically, the equation which we have written over here, okay, that is sum of squared errors. Sum of squared errors. Okay, that is your actual value, you know. Okay, you want to get the predicted value. So what you can do is, x1 we know because that is the observed value and the observed output. Okay, the input and output. Beta naught and beta 1 we don't know because this y cap, that is the predicted output, is represented by this form, linear regression form. Okay, so when I put this, I want to get the sum of squared error as minimum. So what I did, I first put differentiate this by on the basis of beta naught, get the equated to 0 so that I can get the value of beta 1, and similarly I did it for the other things. So that is one how you do it mathematically. If you don't want, there are functions available. Is it fine, Balmurugan? Balmurugan?
Yes, sir.
Okay. Shankar, is it clear now? Okay. So now let's move to the other part. Okay, the other part of your supervised learning, another category, that is your classification. Okay. Now, what is a classification that we talk about? Hello.
Excuse me, sir.
Yes.
Sir, can you tell that example once again, sir, please? You have
Which
taken
example?
2 lines. No?
Oh, okay.
Yes, sir.
Okay. Anybody else? Any other doubts? Guys, any other doubt? Okay. See, what I did is over here, this was my data. The dots are represented by my data. We saw that mean cannot be used always to give the prediction. If there is any dependency, if that data, the output is dependent upon any other feature. So we try to represent it by a line. Okay, because I wanted to get some way closer a place where my data will be represented by a particular line. So randomly I took two lines. Okay, randomly I took these two lines where C was 10 and M was 12, and same way for this one. Okay. Then what I did is one by one, I fed the number of units being replaced. Like this was, like number of unit was 1, which is being replaced. So if I put this in the equation, 10 plus 12 into 1, I'll get some value. Then I will put 2. So 10 plus 12 into 2, I'll get some value. So that will be my predicted value. Okay, based on the line. So I will put observed value, observed minutes we have, that is represented by Y, and the predicted value we can get it using this particular equation. So we did that. This is with respect to the mean. We get the result, which came around 27,000. Then we use the line to get it, which came around 5,000. That means individual time I have put it 1 plus 10 plus 12 into 1, 10 plus 12 into 2, 12, 10 plus like that, the units which are being replaced. Okay, and we got all those values over here. Then we got the error, that is 4993. Same way for the other line also we got 5,001. Now once we get that, we wanted to get the best fit line. We wanted to minimize this error, sum of squared errors. So we use this particular sum of squared error formula, the y minus y cap, that is y observed value minus predicted value whole square. So predicted value I have just replaced it by the, what you can say, I have just replaced it by the formula, that is beta naught plus beta 1 x1. X we know because that is the number of unit which has to be replaced. Y we know, that is the output time, original output time it took. So we wanted beta naught and beta 1. So we use the differentiation with respect with respect to beta naught, then with respect to beta 1, and then we equated it to 0. Am I clear? I'm not sure who asked that question.
Hemant, sir. Yes, sir. Yes, sir.
Okay. Now the thing is, this is another category of the classification. Now let me just ask you a question. Okay, forget about this label. Now this is your input features. Let me talk about, that is I. Okay, this is your classes or the observed values, or you can say the output. Okay, now you just looking at this data. Let me ask you, if we have a movie, okay, let's say we have fifth one, we have a movie which is number of action scene is 93 and number of comedy scenes, let's say, is 5. Okay, so based on our historical experience, like our knowledge, if the action movie is scenes are more as compared to comedy scenes, then we categorize it to the action category. That is our human brain, that is our human mind that has that information. Okay, now in that particular case, if there is another category which is coming up, which is 50 by 50, okay, I cannot create a new category, a comedy, action comedy movie. Either it has to be action or it has to be a comedy. Now where did our experience, our knowledge lack? First thing is, I never said that if the action scene is more as compared to the comedy, then it's an action. It's nothing like that. That is your brain historical data it has. When we are answering the second line, we didn't look at the previous data. Same way, when we answered this thing, we didn't took into the consideration the data which we have in our hand. We used our own brain historical data. That's why we lagged in this. So what will be the category of this thing? Okay. Now, what usually we do is, if you see this is a categories, that is means it's a part of classification and non-regret and not regression. If it would have been a regression, that means it will be a continuous values. Okay, so it's a part of classification. So what we can do is, let's plot this. Okay, and we need to find out the category of the movie. So I'll come back to it. I'll come back to this question again. But before that, I want all of you to answer this one. How many groups do you see over here? How many groups do you see over here? Please answer on the chat box. 3. Okay, I get one answer as 3. 3. What about others? 3. Okay. 1. Okay. Now let's come back to our assumption again. Okay. I gave you a set of input, that is your features. I didn't give anything as an output. Now what are the input features? First one is your color and the second one is your size. Some of you took into consideration the color. If I take into consideration the color, obviously I will have 3 groups. If I take into consideration the size or the shape, I will have 1 group. Okay. Now the question arises is, which one is the right answer? If I take color and shape both, that means if I take both of them together, then also I will have 3 groups. So which feature I should focus on? That is much more important. That's why I said in unsupervised learning, you have a set of input, you have a set of predefined rules. Okay, then you provide an input and you get the output. So neither the system nor us know what is that rule. So if that rule is color, you have 3. If the rule is shape, that it means you have 1. So this is your unsupervised learning. Am I clear, guys? So the best answer would have been color, it's 3, and based on shape, it's 1, because that is the one which you'll have to define in the rule. So I hope now the difference between supervised and unsupervised is clear. We in unsupervised do not have any output. In supervised, we have 2 parts, regression and classification. In regression, we go with the continuous data, and in classification, we go with the classes or the categories. Now let's come back to the same data again. Okay, and we need to categorize this, we need to answer this. Now there's a basic assumption over here. Okay, we try to take each one in a different dimension. So let me take this as an x-axis, this as a y-axis. In machine learning, whenever we proceed, okay, we try to represent our data in the form of dimensions. So if there are 2 dimensions, you have x, y. If you have 3 dimensions, you have 1, 2, 3. Now, what about the data which are having more than 3 dimensions? Sometimes it will be 4. If you talk about hypothetical protein, the number of dimension is 1600. So how we will represent this 1600 into our data set? The thing is, when we talk about the supervised learning, when we are representing in the dimensions, okay, we assume that each feature or each dimension is 90 degree to one another. Okay, so 90 degree to one another means we just assume in our mind. Okay, like in 2 dimension it's clear, but if you try to visualize for 4 dimension and you try to get it 90 degree, you cannot visualize that, so don't even try that. So if you just assume that the lines are represented by 90 degree. So when we have plotted this, okay, we have plotted this, and the one which we wanted to predict is 50-50. That is what we have to predict. Now let's observe over here. Okay, 115. Okay, that is 115. This is 0.1. Okay, 2095. This is 0.2. 95. This is 0.3. And 1085. This is 0.4. Okay. Now you see over here the points which are close, that is 1 and 3, they both belongs to one category, that is action, and that is very much clear. This is a action category. This is the action category. And 85 and 95, this one, okay, this one is a comedy category. The lines are moving very badly. Okay, these are comedy category. Now the thing is, that means if the points are very near, just a second, if the lines are very near to one and another, if the points are very nearer to one another, they will have similar properties. If you think in our childhood, people used to say that don't go with that particular group, otherwise you will acquire the property of that. Okay, you go with the students or studious students, you go with the one which are very good students, so you will be a good student. Don't go with the rowdies, you will acquire that property. Same way, if over here, if you see, if a new point comes up over here, okay, obviously it is nearer to these points 5 and 15, that is first and the third row, so it will have a property of action. Same way over here, you have comedy, you will have a property of comedy over here. Now in this particular situation, okay, if any point which is nearer to one another, let's say if this point comes over here, there, they all will be comedy. So the one which we are talking about, nearness, we are just saying about the nearness. How do we define a nearness? It's just a distance formula that we have studied in standard 7, that is square root of x1 minus x2 whole square plus y1 minus y2 whole square. Okay, that is the formula, the distance formula that we have. Okay, so what I will do from this point, okay, I will compute the distance, that is 50-50 point. I will compute the distance for all these 4 points. Okay, let me say we have computed the distance and we have sorted them in ascending order, and we get the distance like d1 as, then d2, sorry, so we have 1, 2, 3, 4. Okay, so this is distance 1, this is distance 2, this is distance 3, this is distance 4. Okay, so in this particular case, when we talk about the distances, in this particular situation, if I consider only one neighbor, okay, that means, let's say, let me put it this way, just a second. You have d2, you have d3, you have d1, and you have d4. Yeah, now it's fine. So I have computed the distance from 50-50 to all these points. Okay, and I have sorted them in ascending order. So if I consider only one neighbor, that means it's going to be the comedy. If I consider 2 neighbors, I cannot decide it. The reason being is, you want to classify the binary data and you just have 2 outputs together with you, so we cannot classify that. if I take three neighbors, okay, that is D1, D2, D3, the points I'm calling it as a neighbor. If I take three neighbors in that particular situation, we will have a vote. That means this was three was action and one was action. That means now it will be a category action if I consider three neighbors. Same way, how many neighbors you have to define that when you perform the experiment, when you divide into train, test, and validate, you get that. So based on three neighbors, I say that my number of, the category of this move will be action. Okay. On research paper, it has been reported that if the K, the value of K is taken as 5, that will give you the best result. K is actually the numbers which you want to take into consideration, the number of neighbors you want to take into consideration. So this K nearest neighbor over here, it's nothing but it's just involve the steps. You assume the data is in multi dimensions, you compute the distance, you sort it, and then you take the votes, the numbers of K which you want to consider. This is your known as KNN, K nearest neighbors. It's just a representation, Bala Murugan. It's actually this 95 is nothing but it's 20,95. I just forget to put it in the plot. I will update this. This is 10,85. Okay, this is the point. Two values of x and y coordinate. Is it
Okay,
clear,
sir.
Bala? Okay. In KNN, K is the number of clusters. K is not a cluster. 1 second, I'll just take my charger. Just hold on. Just a second, guys. Okay. Yeah. So yeah, K is not a cluster. Okay, it's the number of neighbors which you are considering. If I consider only this neighbor, let's say which was D2, D2 was 2095. If I am considering this neighbor, then what will be my class? If I consider these three neighbors, leaving one out, what will be my class? So K is the number of neighbors which you are considering. Is it clear now? Del, I'm not sure the name. Del, is it clear now?
Sir, once again, please.
Okay. Now, yeah. Now, there are few points which you have to remember. This is one of the very basic algorithms of machine learning, which is K nearest neighbors. Now, how do we decide the value of K? Okay. First thing, if the numbers are binary, the value of K in that particular situation should always be odd. Okay, if the numbers are, it's not working. The numbers are, if the output is binary, like in our situation, the number of K should always be odd. Second point to remember is how to define the number of K, let's say 1, 3, or 5 in our situation only. So what we will do is the data which we have, we will try to divide it into three parts. That is your train, validation, and test. Okay. So what we can do is, using train and validation, we will use multiple values of k, and we've tried to figure it out which k is giving us the best result. Then we will use the test data to give the accuracy of our model by using that value of k, because it doesn't mean that if any future data is coming for all the values of k, you will compute. So first we'll build a model using train and validation. We will define the value of the k based on the multiple experiments which we have performed by different numbers of k, and we have recorded that. Whichever is the highest, we determine that value of k. Then we use the test data to determine the accuracy. So that is a part of your KNN, that is your k nearest neighbor. Sugna, the reason to select the value as odd for binary classification, if you see in this particular situation, D2, the distance from point 2 was comedy, okay, and D3 was action. So if I take value of k as binary, okay, that is 2, if I take, that means I won't be able to decide what will be the category, because 50-50% votes have been given to action and comedy both. So in order to break the tie, we go with the part which is known as we go with the odd values. Okay, is it clear? So if we go with get good and same accuracy for k, which one should we focus on? So yeah, if you get the value of k equals to 5, 7, 9, you should go with the minimum k value. That means if you having exact accuracy for 5, 7, and 9, or the difference in the accuracy is what you can statistically insignificant. Okay, suppose for 5 it is 90.4, and for k equals to 9 it is 90.47. Okay, so that is significantly what you can say insignificant, statistically insignificant. So in that particular situation, you will take the value of the k which is minimum. Max value of k, it is not reported, okay, as of now, because for different data set, based on your data, value of k will be changing. Like the iris data set, value of k as 5 gave you the best result. Okay, iris data, it's a flower data set present on UCI repository. But for my data set, for the face image of the what you can say, the newborn kids, on my research where we found that k equals to 9 was giving us the best result. So it depends, completely depends upon the data, the value of the k. Sugna, is it fine? Sugna, is it clear? Now let me just let me just tell you one more thing. The way, okay, if I take value of k equals to 1, we tried that and we actually got very good accuracy. Okay, suppose, okay, these are one group. Okay, these are one group. Okay, this is another group. Okay, this is another group. Now the thing is, right now when we are computing the distance, we are computing from all the points. You take only 3 distances: nearest distance, then you take the centroid, and you take the farthest one. What does that mean? You have a point over here, okay, you compute the distance from this group, okay, whichever is the nearer, okay, point in this, from all the data set when you have covered, out of this group and this group, whichever point is nearer to win, the k equals to 1, I will classify into this category. So let's say this category is A, this category is A, okay, I, it's not able to write it, and this is category B. Okay, let's say this is category B. This is category B. Now in this particular case, what happens is, when I take k equals to 1, okay, I found that the nearest, I'm just considering only one point from both the groups, whichever is nearest. Based on this, this is came to be the category B. The centroid, I computed the centroid for both the groups, and then I computed the distance. I found whichever is nearer to me. Suppose I found that group A was nearer to me. Okay. Then I computed from the farthest point of both the groups. From the farthest point which is nearer to me, I used to categorize it. That means I'm using only one k value. I'm using only one value of k to determine the output. So for this, let's say it is A only. Then I take the voting scheme and I categorize it into A. Why I am doing this? There has been a situation, many situations. Okay, for example, let's say this is your data. Okay, this is one group, this is another group, or let me just put it with a different color. Yeah, this is another group. Points are there. Okay, and if this is the value for the group which I want to predict, if I take k equals to 2 or k equals to 3, then obviously it will tell me that it belongs to the green group. But that's not true, because the entire data is present over near to it. That's why I'm considering three distances: the nearest one, the centroid one, and the farthest one. Out of these three, whichever is in both the three cases, we take the minimum distance, and then we use the voting scheme. So for this, just with the value of k equals to 1, we actually achieved a very good accuracy, which we published earlier. Is it clear now? Sugna, so value, just a value of single k, or the just k equals to 1, you can come up with a very good accuracy. Am I clear now, guys? Okay. Now the thing is, let's move to another category, naive Bayes. Okay. Now this naive Bayes, what does it means? Naive Bayes is actually designed on the basis of probability. So the first one which we saw, that was just a line. The second one which we saw, that was based on the distance parameter. This one is actually based on what you can say, the probability thing, and it's based mainly on the basis of your conditional probability. So let me just put it this way. Okay, you have one group, this is group B, this is group A, this is group B, okay, and this is the entire set. If we talk about, okay, the universe. Okay, now this section, as we know, this section will be A intersection B, that we know. Now if I talk about the conditional probability, that this conditional probability is the probability of a certain event when another event has already occurred. For example, let's say if I talk about probability of an event A when event B is already occurred, so we can write that probability of event A when event B has occurred as probability of A given B. And that is actually, that is nothing but your probability of A intersection B divided by your probability of B. Okay, probability of B. Probability of B, yeah. Fine. Same way, if I talk about probability of B given A, it will be B intersection A divided by probability of A. That means both the cases, whether A given B or B given A intersection B has to be the same. So if I try to put it this way, okay, if I try to put it this way, probability of A intersection B is nothing but a probability of A given B into probability of B, okay, equals to, this is also equals to probability of B given A into probability of A. Okay. Can we say that? Because this A intersection B, it's common in both the places. Okay. So if I try to solve it, that means simply B by A, probability of B by A is equals to probability of A by B into probability of B divided by probability of A. This is your naive based formula. It's nothing much. It's just a probability. This is what you get. Any other doubt? Guys, any other doubt? Is it clear? So I'm just talking about in terms of probability. It's a Venn diagram that we have seen earlier. So this is what Bayes' theorem is. Same way, if I try to expand this, okay, let me put it this way, okay. Probability of a people having fever, okay, given typhus, suppose given COVID, okay, you have 98%, okay, and probability of fever is just, let's say, 10%, and probability of COVID is just, let's say, 5%. That means the probability, if the person is a COVID patient, okay, 98% chance that he will have fever. Probability of fever is 10%, probability of COVID is 5%. So now this is given a COVID, what will be the probability of the fever? If I want to find out what will be the probability of a person being a COVID patient given it is a fever. So that will be defined by this P, what you can say, the 0.98, 0.98 into 0.5 0.5 divided by 0.1. Okay, this will be the probability that a person, the person who is having a fever, whether is a COVID patient or not. That is a difference. See, if I say P fever given COVID and P COVID given fever, if a person is having a COVID, what the 98% is the probability that he will have a fever. But if a person is having a fever, if you solve this, you will get around 49%, 50%. If a person is having fever, he will have a COVID symptoms. Okay. Now, if I talk about the features, okay, same way over here, the one which you see, this probability of C given X, okay, that means P X given C will be given to you. Probability of class probability, you know, the predictor probability, you know, okay. So this X attributes, that is, you can define it by X1 given C into X2 given C, so on. Now, in this particular situation, this X1, X2, X3, these are your features which are available. Okay. So if you see over here, this is the data which we have. Okay, that is the naive base. So first one is your day, second one is your outlook, third one is your temperature, fourth one is your humidity, fifth one is your wind, and you have a prediction for play golf. So now what happens is, when you go with this, if you are predicting whether the game of golf will be played or not, okay, that is your prediction which you want to do. So in that particular situation, first I'll have to look into the consideration all the parameters that we have, that is outlook, temperature, humidity, and wind. So what I will do is, looking at this data, okay, for the overcast, for this is outlook, that is your overcast, temperature and all, I have recorded this probability thing. Now what I have done is, in this particular situation, I have just written, I have taken when it was sunny and the match was played, that was 2 times. When it was sunny and match was not played, that was 3 times. Okay, same way, probability of given total matches that were played, that was 14, out of which 9 matches were yes and 5 matches were no. So we got the probability of sunny, that is 2 by 9 when the matches were played when it was sunny. Then the overcast thing, we get 4 by 9. That means when it was overcast 4 times, that is your probability 4 by 9. Then when it was overcast, there was not a single time when the match was not played, that what you get 0 by 5. Okay, does it look simple till now? Is it clear, guys? Sugna, we will use this whenever we have a classification data. Yes. Now the peoples have come up with KNN with regression, naive base with regression. There are other variations which people have come up, but right now it is just for classification. So same way, we try to compute it for your humidity, we try to compute it for temperature and the wind over here. Okay, we computed all this probability. Now the question is, what will be the temperature? Let's say if I talk about, we talk about, let's say when it was, we talk, let's say D3. Okay, we want to predict it was overcast, hot, high, and weak. Okay, we want to predict this. So it was overcast. That is the probability of given this. That is 4 by 9. Okay, 4 by 9 into. Then the second one was hot, high, and weak. Okay. Then hot, that was 2 by 9. 2 by 9. Shit, it's not working, my pen. That means you we will have to, based on the formula, we will have to multiply this 4 by 9, 2 by 9, the one which we have, this one. Then you have high, that is 3 by 9, and then you get 6 by 9. Sorry, the week, that was normal. Okay, 6 by 9. So you will get, when you do this, you will get the probability of yes, the game was played given all the different conditions. Okay, they given all the different conditions. That was, let's say, the x1, x2, x3, like that. Same way, you will have to compute the probability of no given all the condition. That means 0 by 5, 2 by 5, then 4 by 5, and finally 4 by 5, this one, and 3 by 5. Fine, probability of no given all the features. Okay, so obviously this will be 0 and this will be 100% because this is 0 by 5. That means yes, the game will be played. So this is another way through which you can achieve this result. This naive based, the Bayesian theorem has actually proved earlier, it has proved or has shown a significant result in terms of medical data. Am I clear? Guys, are these points clear to you? Any doubt? Please respond. These points are clear to you? Sugna, we cannot just determine like and say that whether a particular algorithm like KNN, naive Bayes, and all are good or bad. Okay, it completely depends upon the data. Okay, when the property of the data are changing, your classification will change. For example, KNN is not suitable for the data like this one, the cancerous data. Let's say if we have a data like this, okay, and other the data are another group is represented by this. Another group is represented by this. Okay. KNN is not suitable for this. KNN assumes that the data should be in a spherical and they should be apart from one another. There should not be any overlapping. Your naive Bayes, your decision tree, your regression will be a good example for this. Again, non-linear representation, because over here you will have to put a form of line like this in order to classify this. Because if a point is coming to this particular place, okay, it will always categorize into this category, which might not be the true. Okay, so the way your data are represented, that you have to do. So how do we decide based on the data? By looking at the data, at least few steps we can categorize it. That means we can say that okay, it's a part of unsupervised or supervised. If it is continuous, that means it's a part of regression. Now whatever is left with the what you can say, the classification thing like KNN, naive Bayes, random forest, decision trees. Okay, in these, ensemble techniques actually gives you a better result. What is an ensemble technique? Ensemble technique means instead of just relying on one classifier, you try to train multiple classifier and try to get a voting scheme. Like random forest. Random forest is nothing but it's just a combination of multiple decision trees. Okay, so it has been proven that ensemble techniques gives you a better result. But among your what you can say that decision tree, naive Bayes, logistic regression, KNN, other classifier, rule based classifiers and all, it is very difficult to decide because it completely depends upon your data. So ensemble techniques you can try, like now the deep learning features like CNN and all has come up. So using CNN, it gives you a better result. Okay, is it clear, guys? Okay. Any other questions? 15 minutes are left. So if you have any queries, any doubts, then we will discuss it right now. Because decision tree and other classification algorithms, it won't be possible for me to cover in such a small time. Okay, so I won't be covering it. Guys, any doubt? Who Shankar, was that doubt clear? The one who asked me earlier?
Okay.
Shankar?
Okay,
Yeah,
okay,
got it?
sir.
Okay. Any other doubt? Okay, Sunita, thank you so much. I hope I am able to convey what is a supervised learning and how we approach. The terms look very big, the machine learning things, but it is all the things which we have done in standard 7, 8. The distance parameters, the representation of a line, the probability thing. Okay. So if we still have time, so if you have any doubts, any queries, just let me know. Can we get Can we get case studies with code? Okay, I have one link with me, Wikibooks. It is for R, not for Python. Okay, so if you go over here, you see over here the dimensionality reduction, clustering, classification. If I go to classification, sorry, this is clustering. if I go to classification, there will be few algorithms which they have defined. So let's say KNN I'm talking about. So they will give you the introduction, brief background, the algorithm, the mathematical part, a small example, and a complete case study over here. Okay, but the code will be in R. So for other algorithms, you can just refer it over here, but the coding for that you'll have to go with the Python. Is it fine, Del? Del, is it clear? I hope you are looking for some kind of this thing. You have the mathematics introduction, everything with a proper case study. Okay, yeah. Python, as of now, Sugna, I haven't found any such things which gives you the all the places in one thing. I prepared a script. Let me just check. I prepared one where all the KNN and KNN logistic regression decision tree and all were there. Using one example, we compared it. But let me just check, Sugna. I'm not sure where it will be because I did it long back. Okay. And I thought it was a theoretical session. That's why I didn't enter into the Python code. Otherwise, I would have got that. At least the idea is clear, Sugna. The thing. The code will be available online. If you search, you will get that. Okay. For R, the one which I shared, that is one of the best link I have found. Okay. Okay. Any other doubts? Thanks, Sugna. Any other doubts?
Sir, I have one question.
Yes.
Sir, I have one question regarding the text classification. I want to ask which technique is better for text classification, supervised learning or unsupervised learning?
Ma'am, it depends upon the problem statement which you are going for. For
Sir,
example,
for
if you are, yeah, if I going for some, let's say, what you can say, uh, categorization of on the basis of news. Let's say I say that the number of deaths in a city, okay, number of deaths in a city is a different, number of deaths due to accident is different, number of deaths due to murder is different, number of deaths due to poison is different. So all of them will have a different data. So that is a hierarchical clustering which will form. Okay, we cannot just go with the k-mean. That will be hierarchical clustering. Some places, most of the time, what I am seeing these days is people are going with classification with clustering, where they are first trying to group on the basis of cluster and then they are trying to classify that. So clusters they will form, they will not know what group it will be. The only thing which they will know is, okay, they have similar properties. The domain expert will have to come. For example, let me just show it this case again. Yeah, in this graph, if I just remove the labels, okay, my points will still be there. Okay, it will have the same properties. The only thing is I do not have the labels, but I know yes, 85 and 95, these points will have the similar properties. So that means first I will group them. Then when this 50-50 is coming, I will classify them. So there's a classification based on clustering. This is one of the approach which people are following these days. You can look for that, ma'am, as well. But whether you want to go with supervised or unsupervised, that is a very big difference in the area, ma'am. And it becomes very difficult to get a supervised text data in NLP. Otherwise, you will have to gather it. In case of supervised, NLP is something which has really proved good and has shown a significant improvement. Is it clear, ma'am?
Yes, sir. Sir, I have one application like sentiment analysis in machine learning. So, if we want to categorize the data using the sentiment analysis like binary classification, so
Yes.
for this, in case of supervised, the output is already given, but in unsupervised, we are not having any output. We are having only input data. So
Correct.
if in unsupervised, if we are using only input data, so is it accurate, more accurate? Which one is more accurate for this binary text classification?
Okay. See, first thing is in unsupervised data, like I said, neither the system nor we know that what will be the result. So we cannot claim that whether the data, the result which we are getting is good or bad. You get my point? In classification, I can say that my system is 100% accurate. My system is 90% accurate. If my in case of let's say unsupervised, whatever error I get, I'm not sure about that. It can be anything. Did you get my point? So in case of that, your analysis, in case of unsupervised learning, your analysis is more important. We cannot just say that classification or unsupervised which one is better, because they are completely different domain. It's like a computer science and it's like a mechanical. So either you go with mechanical or you go with this particular thing. But people have tried to bridge this gap using the classification based clustering.
Okay, sir.
Okay. Sunita, this few links I know which I have been recently using. So you can also refer to these links. They provide data sets and all. Any other question, guys? Welcome, Sunita. Thank you so much.
Sir, sir, if we take an image, what may be the possible features, sir, except statistical features? Because I'm working on vegetation. I have taken around 10 statistical features, and I'm looking for other possible features which may help for to improve the accuracy
You're going for a classification,
of diseases, plant diseases.
plant disease. Sir, I would say statistical features now it has actually the CNN and the pre-trained models. The CNN and pre-trained models like transfer learning people are using, and they have actually outperformed all the machine learning and the statistical methods. If your data are very small, it's better to go with the pre-trained model, or you can call it as a transfer learning, where you can directly go with the prediction thing. Okay, instead of building your own model and training it, you directly go with the transfer learning part. They have actually proven very good results. We did this on projects when I was in my previous institute. We gathered that data, okay, and we performed that this transfer learning accuracy was above 95% for more than 24 or 25 diseases which we picked. So you can look for this pre-trained transfer learning steps. This link is not working. I just checked it. You just type UCI iris data set. Okay, you go to this archives, and you go to view all data set. It's working. Oh, actually, it got copied 2 times. That's why it might not be working. Okay, is it clear, sir? I guess Vijay Kumar asked that question. Any other question? Guys, any other question? My mail ID is, and Sunita, Sugna, you can just drop me a mail. I will share my phone number with you. Okay. Once you drop me a mail, I will definitely share my phone number with you guys. Thank you, Sugna. Guys, anything else? Shall we wind up? Okay. I will have to look for Dell. I will have to look it for that the scripts because I didn't prepare it. I thought it was completely theoretical part, so I didn't created that. Let me just see if I get any link, external link. I will definitely share it with you.
This conference is no longer being recorded.
Thank you. Thank you, sir.